So this is the question. There's 1 liter buffer solution that is 1 molarity acetic acid and 1 molarity of sodium acetate. Calculate pH after the addition of 0.1 moles of NaOH. So you can see that even if they didn't say it was a buffer, you can see that it would be a buffer because acetate is the conjugate base of acetic acid. So that's how you tell it's a buffer. So for this problem, it says they want the pH after you add NaOH. So the first thing you need is a chemical equation. So when you create this chemical equation, you have your acid, and then you have this addition of NaOH. Notice how the Na doesn't show up here. That's because Na instantly it dissociates. So because it dissociates, the Na doesn't have to be there. And if you put it there, it would just confuse you. And notice how it's only a forward reaction because it's not equilibrium because it's a strong base. Strong base dissociates, so you don't need a reverse reaction because it completely dissociates. It doesn't form together to create reactants. So that's the equation, and now you just plug in your information that you have. So for acetic acid, you have 1 mole. Molarity is just moles over 1 liter, so it'd just be 1 mole. OH minus, they said it was 0.1 moles. And then acetate ion, sodium acetate will dissociate into sodium and acetate ions, making it 1 mole, because molarity is just moles over liters. So now, since you have all of that, what you do is these two will react to create more products. So that means that this will become 0 because it's reacting with the weak acid. So you're going to subtract 0.1 moles from this, making this 0, and then 0.1 moles from your weak acid. So, and if you subtract 0.1 moles, you're subtracting it so that you can create more products. So you're going to add 0.1 moles here. So once you're done with that, you're after the reaction is complete, it'll be 0.90 moles, 0 moles, and 1.10 moles. Now you have to use this information to get pH. Now there's a formula that'll do that for you, and that's the Henderson-Hasselbalch equation, and that's pH equals pKa plus log conjugate base over your acid. So and you have this information, and they gave you the volume too, so you can calculate molarity. But also, even if they didn't give you volume, if you use moles, you'll still get the right answer because it'll just the volume just cancels out. So for this equation, what do? So Ka is 1.8 times 10 to the negative 5 for acetic acid. So you plug that in, and pKa, the equation is to find pKa is negative log of Ka. And like I said, the Ka is 1.8 times 10 to the negative 5. So now you just plug in the other information, which is the conjugate base, which is 1.10, and the weak acid, which is 0.90. So you just plug that in to each of these, and then you just you do the math, and you will get pH equals 4.83.